Okay, so next up is translations, reflection, stretching, etc. for exponential functions. Sorry. We've got here, this looks like this is y equals 2 to the x, which I can tell because it is doubling every time I increase x by 1. So the same principles for vertical and horizontal translations and reflections hold as what we did in chapter 3 and in chapter 5 when we learned about those with just straight up translations and reflections, and then with them as applied to polynomials and power functions. So if I've got f of x equals 2 to the x graphed here, what is the negative 2 to the x going to look like? Hopefully y'all are saying, well, the negative is going to reflect over the x-axis, right? So I'm going to have points. Let's put this in a different color. I got, instead of 0, 1, I got 0, negative 1. Instead of 1, 2, I've got 1, negative 2, negative 8. Sorry, negative 4. I missed a point, right? Negative 8. And so it's going to look pretty much the same. Let's see here. I'm going to connect my lines there. Look like that. All right. So it's just the graph reflected over the x-axis. All right. So let's go on to a few more, right? So basically we're going to say, hey, what are the transformations that are going on here, right? And so this, we can think of this first one, 2 to the x minus 1. This is kind of like saying, okay, I've got y equals 2 to the x, or f of x equals 2 to the x. What happens if I do f of x minus 1? That would be 2 to the x minus 1, right? And we know that this x minus 1 is an inside change. That is a horizontal shift to the right. So this is going right 1, right? Horizontal shift right 1 unit, right? And so if you just write 1, I'm going to know what you mean there. So we can say, okay, I just need to take each point and I'm going to move it, this one over, and see this one over, and then we're going to connect the dots. And as best we can, there we go. So there's our first one. We'll go to blue, and we're going to say, okay, what's going on here? Well, we've got our original f of x function, and then we're subtracting 3. So this is a vertical shift down 3 units. So every point that was on the original one, go down 1, 2, 3. 1, 2, 3. 1, 2, 3. And of course, our horizontal asymptote is now shifted down 3, 2. So I know that I have a horizontal asymptote instead of the x-axis, that one's going to be at negative 3. And let's see, this one would be at 8. So 1, 2, 3. So we'd have one here. And so these guys are going to cross. But, you know, you get the idea. Really? All right. So what else we got? The next one, 2 to the negative x. We can basically think of that one. Let's make that one in green. All right. This is like, what would happen if we did f of negative x? That would be 2 to the negative x, right? So this, we can see this. We remember, oh, that was a reflection over the y-axis. All right. So we are reflecting horizontally, basically. So we're still going to have that 0, 1 point, but this point here at 1, 2 is going to go to negative 1, 2. This point at 2, 4 is going to go to negative 2, 4. The point at 3, 8 would be at negative 3, 8, and so on. And so we could, really can't draw nice curves. And so our graph would look something like that. I got close, right? And then this last one is a little tougher. okay, because we know we have a translation in here, but we actually also have a reflection. So this one, I'm going to encourage you to write this as 2 to the negative x minus 4. That is algebraically the same. What that says is that we have a reflection over the y and a horizontal shift right 4. Okay, and so you can do this whichever way you like. I would say reflect first, so we've got the green one, and we're going to move that thing to the right by 4. So 1, 2, 3, 4, 1, 2, 3, 4. So, and our horizontal asymptote is not going to change, so we've just got those. So we're about here, and so we should look roughly like that. All right, so let's double check that one. We're going to do y equals 2, what was it, to the negative x. So that looks not surprising. Y equals 2 to the 4 minus x. And is that kind of agree with what we had for our graphs? I think it does. Let's make this a little bit, there we go. So roughly speaking, that looks pretty much like our green one is the red one on GeoGebra, and our purple one is the blue one on GeoGebra, which looks a lot better on GeoGebra. All right. So you should be able to go both ways with this. Write an equation that represents this graph by using transformations from y equals 3 to the x. Okay, so first off, we know that it's been shifted because we can see our horizontal asymptote is at y equals negative 3. So we know we've got a transformation that we went down by 3 units, right? And let's see here. So if we shift this thing back up, we would be at 0, 1. We would be up 3, so we'd be here. And we can see pretty quickly that there's not been a horizontal shift because we have, if we shift our points back up, the 3 that we know the vertical shift has happened, our y-intercept's at 0, 1, right? And our ratio, 3 of our points, we've got that ratio 3 over 1, but it's been reflected, right? So we've got a reflection over the y-axis. So that means we're going to have 3 to the negative x, because that's going to flip it across the y-axis, and then we're moving it down 3 units. All right. So what's our range here? We're going to be going from negative 3, but not including negative 3 because that's a horizontal asymptote that it never reaches, all the way up to positive infinity. I'm going to write our horizontal asymptote a little bit better here, negative 3. Vertical asymptotes, there are none for exponential functions. All right. And then I think we'll sneak in, yeah, we do this last one, and that will be another good breakpoint, and then we'll have one more chunk. Okay, so we're going to determine the following for the function. We've got this negative 1/2 to the x plus 1 plus 4. All right, so it's an exponential, right? But it's been shifted and stuff, so our domain is still all real numbers. Our range we got to think about, right? But so let's think about what transformations are happening here, right? The plus 4 is going to move us up 4, right? The x plus 1 is going to, that's a horizontal shift. And we are going left by 1, right? And this negative right here, we are reflecting over the x-axis. So in terms of sketching this without using GeoGebra, well, first off, we would want to sketch 1/2 to the x, right? And so anything is, so if we sketch y equals 1/2 to the x, We know that's decreasing because our base is less than 1. We know it has a y-intercept of 1 because the unspoken, unwritten a there is 1. If I plug in x equals 1, I'm going to get y equals 1/2. If I plug in x equals 2, I'm going to get 1/2 squared, which is 1/4, and I get really small numbers, right? If I plug in -1, I'm going to get 1/2 to the -1, which is 2. If I plug in -2, I'm going to get 4. And so here is our base function, y equals 1/2 to the x. So the next shift, the first transformation is a horizontal shift left 1. So we're going to say, okay, let's move all these points left 1. Right? So we've got that. All right, so the blue one's going to be y equals 1/2 x plus 1/2 to the x plus 1. Then we're going to say, okay, great, I've got to reflect that over the x-axis, right? So that's the negative. So we're kind of working PEMDAS here. So we've got, let's see, that's about a 1/2, that's about a 1/4, this is a 1, negative, and let's see, -4, right? So we're mirror imaging this, reflecting it over the x-axis. There we go. So this is y equals -1/2 to the x plus 1. And then lastly, we're going to move everything up 4 points, right? So this guy's going to go up 1, 2, 3, up to about 3.5. This guy's going to go up to 3. So my -1 is going to go up 4 points. My -2 is going to go up 4 points. My 1, 1/4 is going to go up to just under 4. There we go. And so, and my horizontal asymptote is going to move up 4. So we know, except that I can't draw in a straight line, that my new horizontal asymptote is going to be y equals 4. I also know that there's no vertical asymptotes for exponential functions. And we can go ahead, oh yeah, I forgot to move this one up. Let's see, the -4 point, move that up 4, so we're going to be right here. So there we go. There, close, is our y equals -1/2. I've got to be careful how I draw that. So the x plus 1 plus 4. And we did that all without technology. Now we can answer, so we already answered the domain. Our range, we can see from this that it is -infinity to 4. Anytime you're asked about range, you can always just graph it unless it's a no calculator problem, right? And our y-intercept, you can always plug in x equals 0, right? So we can say, hey, what is f of 0? It's -1/2 to the 0 plus 1 plus 4. So that's going to be 3.5. Did we end up at the right place? Sure did. There we go. Next up, money.